This question is asking us to provide the major organic product. So the first thing to note here is we have this secondary carbon attached to a good leaving group, and we are reacting with sodium ethoxide, which is a strong base. And you should know that anytime you have a secondary carbon with a good leaving group and a strong base, that you're going to have an E2 reaction, and that's what we're going to have here. And in an E2 reaction, the strong base comes in and it takes a proton off of the carbon that is adjacent to the carbon with the leaving group on it. And you'll often hear this carbon referred to as the beta carbon, with the alpha carbon being the carbon that has the leaving group on it. But for this specific reaction here, we should note that we have two different beta carbons. And that's important because if the base takes this hydrogen right here, we'll end up with a double bond here, giving us a internal double bond. Whereas if we react with one of the hydrogens on this methyl group, we'll end up with a double bond here, giving us a terminal double bond. So since that gives us different products, it's probably pretty important to figure out which hydrogen we're going to be reacting with. And the way to figure that out is to go by what's called Zaitsev's rule, which basically just says that if you don't have a bulky base, which we don't, this is not a bulky base, then you react with the hydrogen that will give you the more substituted double bond as a product, and that's going to be this beta carbon for this molecule. And you can see that because if we take this hydrogen in an E2 reaction, we'll get a double bond which is internal, which would be called the Zaitsev's product. But if we take a proton off of this carbon over here, we'll end up with the less substituted terminal double bond, which would be called the Hoffman product, which you don't get unless you're reacting with a bulky base. So because we're not doing a bulky base here, we will end up with the Zaitsev's product. So we know that we're going to end up reacting the base with this proton right here. But that doesn't give us our answer yet because there's still two different possible arrangements about the double bond we can have. We can either have the hydrogen on the same side as a methyl group, or we can end up with the hydrogen on the same side as the ethyl group. So the way to figure out which of these we're going to get is by considering that the proton that is getting taken by the base has to be what's called anti-periplanar from the leaving group. And basically what that means is the leaving group has to be as far away as possible from the proton. So I'm just going to redraw this now so that we have our hydrogen anti-periplanar from the leaving group. And I'm going to do that by just rotating these substituents around this bond right here. So our methyl group is now going to go into the page, and our hydrogen is now going to be coming out of the page towards us. And I'll just redraw this right here, our ethyl group. So now, just by looking at this, we know that we're going to have our ethoxide come in. It's going to take the proton. We're going to form the double bond and kick off the leaving group. And now you can see that we're going to have these two methyl groups that are both going into the page. They're both going to be on the same side. And we're going to have the hydrogen and the ethyl group, which are both coming out of the page, coming towards us on the same side also. And that is this product right here. So that's going to be our answer. And if you're not comfortable with drawing them out like this and figuring out that way, there's another way, which a lot of textbooks do, which is to draw the Newman projection. So just pretend you're an eye looking down this bond axis from right here, and what you would see is the ethyl group on your upper left, a methyl on your upper right, and your hydrogen. And then on this carbon behind it, you would see a methyl group straight above, bromine on the lower left, and a hydrogen on your lower right. And now with this, I guess it makes it a bit easier to put these substituents so that they are antiperiplanar. So this is the hydrogen that's going to react with the base, and we need to have the bromine up here. So you can just redraw that so that our bromine is antiperiplanar now, and now we'll have our methyl group on the lower right, and we'll have hydrogen on the lower left. And now when the ethoxide comes in, it'll do all that stuff, and we'll end up with the ethyl group on the same side as the hydrogen, which is what we get from the other method too. So, and the methyl group's on the same side. So this is the other way to do it, but both give the same answer, which is a pretty good indication that our answer is correct. And this is the major product for this reaction.